Hey folks, let's take a look at this one. So this is for chapter 1, section 8, where we are showing a round world on a flat map. And if you remember, any flat map is going to have distortion because we're taking something that's three-dimensional and we're making it two-dimensional, just like that picture of the guy's face or head. When we took it and we flattened it out, it made it look funny. Okay, same thing applies. And today specifically, we're looking at a couple different map projections that geographers have created in order to show very specific things. Okay, they choose to distort different parts of the Earth so that they can focus on other aspects. All right, so if you haven't already read through the text, please stop the video and you can read through that. I've highlighted some stuff, and then we're going to talk about the stuff that I highlighted as we take a look at the assignment. All right. Okay, cool. So we have a total of 4 different map projections here that we're talking about. Okay, the first one is the Eckert-4 projection, and this one shows the sizes of places accurately, but it distorts the shape, especially near the poles. Okay, so the sizes are pretty good, but the shapes are a little bit wonky. Okay, so that's the Eckert-4. The Mercator projection shows directions between places accurately. This is like the traditional, explorer map. It says that it was made in 1569. Okay, and it's square and it shows direction, but it distorts the size of the different continents. If you look here, like Africa is way smaller than it's supposed to be on here, and like Antarctica looks huge, and there's just kind of some interesting stuff with it. So that's the Mercator one. All right. This next one is the Goods homolosaline. Wait, homolosaline. Homosaline. I have no idea how to pronounce that. I think I messed it up or said it differently every single year. But anyways, it helps us to see the exact sizes of the continents, but it messes up the shape of the oceans and the size of the oceans and the distance between these, because it's kind of like if they just took a globe and they skinned it and then they laid it out. If you've ever been like a hunter or anything. So anyways, it distorts the oceans, and also like directions and stuff are going to be a little bit off, but specifically the shape and size of oceans is off with this one. And then the last one, this is kind of like if in the Goldilocks world of map projections, we have the Robinson, which it tries to balance all the different types of distortion, and the goal here is making a fairly accurate map of what the world looks like. Again, not perfect, but this is a good middle ground. It has a lot less distortion overall than other ones. All right, cool. So we're going to use that as we go through and we work on our assignment for this one. So the first thing we need to do here is click Show Your Work. Nice. And it says label each map projection with its name. All right, so we're going to click on the text button here. How big is that? Yeah, that's perfect. And who is blue? Now it says label each map projection. So this first one, they are kind of in order, and they're the exact same order they are here. We have the Eckert-4. Eckert for 4. Cool. That's the one that distorts, especially near the poles, but it distorts shape. Okay, but it keeps the sizes of places pretty good. Now, for the next one, we have the Mercator, and this is the one that's square, and it shows direction pretty well, or pretty good, and then it distorts the sizes of the different continents. Cool. And then this is the next one we have is the Goods. Goods homolosaline. I think that's how it's homolosaline. No, apparently spell check doesn't have it either. That's good to know. Homolosaline. We'll screw that down. Cool. And that's the one that makes the oceans look way different than they actually are, but it keeps the continents pretty good. All right. And then our last one here is good old Robinson. Meet the Robinsons. And this one is a fairly balanced version of what the Earth looks like. All right, cool. Now, we're not done yet because we've got some stuff we got to do. The first one says circle North America in orange. And for all of these, we're going to be circling North America, but in different colors and in this case, circle North America in orange on the map projection that shows the most area distortion. Okay, so if we're looking through here, the Mercator, it says, distorts the size of the continents. This is called area distortion. So in orange, so we're going to change the color to orange. We're going to click here, and we are going to circle North America, woo, on the Mercator projection. Nice. Next one, circle North America in green on the map projection that does not distort area. Okay, so if we're looking here, remember the one that keeps the sizes or the area of places, it is the homolocine, the goods one. Good. So we want in green, we're going to circle the homolocine one. Woohoo! Oh, I forgot an O. Whoop. I bet you guys in the video were like, Mr. Colson, you spelled that wrong. There we go. Maybe that's why it was saying that as well. I probably should have double checked that. All right. Next, circle North America in purple. So let's go to purple. The map projection that shows the most shape distortion. Okay. So for shape distortion, remember that's up here. Okay. This one right up here shows the sizes accurately, but it distorts the shape, especially near the poles. So we're circling North America in purple on the one where shape is distorted, and that's this guy. Okay, nice. And we're not going to use the process of elimination, just circle North America on here. I'm guessing we probably are, but let's double check. It says circle North America in black on the map projection that has a balance between area and shape distortion without affecting the oceans. Okay, it's going black, and there's only one left, but we can see here that it is the Robinson projection. The Robinson projection kind of has a balance between all of the different types of distortion. Cool. So that was the first part of this. We have labeled and circled the correct maps for this one. Let's go next. All right, and here we have a bunch of, now I think is it now and here at the same time, we have a bunch of different multiple choice questions. So it says, you own an outdoor adventure company called Exploring Happy Little Trees. I don't know. That specializes in sailing trips. So maybe not. In sailing trips throughout the Atlantic Ocean. You need to be able to determine accurate direction. Which map is most helpful for you? Okay, so for remembering which map is most helpful for direction, okay, it looks like the Mercator projection is one that was historically used, and that was pretty good with directions. So let's go with the Mercator. Yeah, cool. For number 3, you work for the United Nations, studying how many people live per square mile in various countries. You need to be able to determine the accurate size of land. Which map projection is most helpful? Okay, most helpful for determining the square miles on land specifically. So if we're looking at these, if we're just focusing on land, then cool, this one's going to be super helpful. The Goods homolocine one, because we don't care about the oceans, we're just looking at the land. So that will tell us the accurate size of land. Nice. For number 4, you work for a book publisher that has to present a fairly accurate picture of the world. You need to avoid lots of area or shape distortion. Which map projection is most helpful for you? Okay, so as far as a balanced one, we're looking at the Robinson. That's going to be pretty helpful. Yeah. Cool. Yeah. Book publisher. Yeah, okay. For number 5, you study ocean life along the coast of Antarctica. You need to be able to see a continuous view of the ocean along the coast. Which map projection is the least helpful for you? Okay, so if we're looking for one that's going to be the least helpful, okay, the least helpful. Oh, actually, I might have. No, I guess for this, for number 3, because I was thinking a little bit of process elimination, but no, for this one, it's used to different areas. For most helpful, determine the accurate size of land. No, I still think this one's going to be the most accurate. This one, it shows the accurate size, but it's not per square mile in countries. Size of land. I mean, for this one, I would take either the accurate or the goods one. Like those are both pretty good, and I think you can make an argument for either. Okay, 4. This one, though, if you study ocean life along the coast of Antarctica, you need to be able to see a continuous view across the ocean along the coast, which is the least helpful for you. That is easy because if you're looking at one of these, there's only one that does not show the continuous view for oceans, and that's the goods hull side. That one is not good for that. All right, so I hope that helps, and I might think a little bit more about number 3. So I'll add an edit at the end if I want to change this. But for this one, per square mile, I mean it's. Nah, I guess probably if we're looking at the most helpful, it'd probably be the Eckert 4. Just because this one it's specifically used to show number of people in areas, and the only thing is the shapes, and I guess we don't care about the shape. We're just looking at the size. Okay. So for number 3, I guess you could pick Eckert, but I wouldn't yell at you if you chose this one either, because it shows the accurate size of the land. All right, cool. I hope that helps. I mean, if you got, well, actually you won't be able to, let me know in the comments on this if you have questions. All right, cool.